Right. Let's work on the fifth problem from the list, and the problem is called majority element. Let's see what is the problem asking. So, given an array nums of size n, return the majority element. Now, the majority element is the element that appears more than n by 2 times. So, if the element appears more than half, then it's considered as the element as the majority element in the array. Now, it is also given that we may assume that the majority element always exists in the array. And if you go over and look at the constraints, you will also see that there is a follow-up where it says, can you solve the problem in linear time and in O1 space? So what they are essentially asking is, we are not allowed to use a hash map to count the frequency of the elements appearing in the array. We have to solve the problem in linear time, which means we have to solve the problem by scanning the array in a single pass and not use any extra space. So let's see how this problem can be solved. So it's given that a majority element appears half plus x times in the array, which means more than half, and it is also given that input will always have the majority element. Now let's take a look at some examples. Like, let's say if the array was of size 10, let's take a smaller number, let's say 7. Now let's fill this array with the same element. Now in this case, 1 is the majority element because clearly it appears more than half times, which is 3. So 1 is majority. Now let's consider another scenario where we still have 1 as the majority element, but it is only present in the first half of the array. So in this case, 1 is majority element. Now let's say another scenario where it is majority element is equally spaced from all the other elements present in the array. So in this case also, 1 is the majority element. Now it is given that we have to solve the array in O of n time, which means in single pass. So usually in problems like this, the intuition you should follow is that at every step, we should know what is the majority element. If we know at every step what is the majority element, or we can take a decision here that whether the current element can be a majority element or not, then we can use that logic to build up on the solution which works in a linear time. So anytime you have to solve a problem in linear time complexity, think about at a current index, what is the decision I can make which might lead to a solution for the array at this point. And then you keep repeating that until you have reached the end of array. Now, one more thing to notice is that we don't care about other elements which are not majority elements. So it doesn't matter what numbers are here in these indexes. It can be 2, 3, 3, or it can be the same number which is not a majority element, but it's the same number which is repeated, or anything else. We don't care about them. So basically, the problem boils down to array having a majority element and a sequence of non-majority elements. So let me write it like this. Now, if you do a single pass, as I said, we always have to know what is the majority element. So in this algorithm, what we are trying to do is we have to find what is the majority element, but we don't know that. So if we don't know that, what we can do is we can assume that whatever index we are standing at, or the pointer is currently pointing to in the array, we can assume that this can be a candidate majority element. Now, every time we find that by moving forward, we find the same majority element again, as in this case, you go forward and you find 1 again. What we can do is we can increase the count of the element which we are having as a candidate for the majority element. So in this case, what will happen is we'll start iterating at the first one. We'll say majority element is 1, frequency is 1. We go to the next one. We say majority element is 1, frequency is 2, and 3, and then 4, so on. The moment we see that we have encountered a number which is not a majority element, what we do is we try to reduce the frequency of the majority element, and we keep doing that. So given that this assumption holds that the array will always have a majority element, we will always have a condition where the count will not become less than 0 for a majority element. So given the assumption that array will always have majority element, if we start counting the frequency by incrementing every time we see the majority element and vice versa, the frequency will never be 0. So we can also use this as a decision making logic, where at any given point during the linear pass, if the current frequency of the candidate majority element goes down to 0, which means we have cancelled out all the majority element with the non-majority counterparts, and then we have to choose a new candidate for the majority element. By the end of this iteration, the candidate which will be picked as part of the linear pass is going to be the majority element. Now, this algorithm is called the Boyer-Moore voting algorithm. I did not come up with this, but I am trying to basically explain an intuitive way to reach to the same solution. So let's see how this works in code. So let me remove this from here and put it on top of the method as a method comment. Now, as I said, that since we have to find the majority element in the linear pass, we will assume that whatever element we are currently pointing to is the majority element. The iteration of the array will start from the first index. So we will say the candidate majority element is the first element and its frequency is 1. Now we start iterating on the array and we iterate from the first index to the end of the array, and here comes the decision making part. If the current element is equal to the candidate, which is the majority element, then we increase its frequency. Otherwise, we decrease its frequency, and if at any given point the frequency becomes less than 0, then we're going to choose a new candidate, which is the current element, and we're going to reset the count to 1. And since the array will always contain a majority element as given in the input, we are safe to say that this candidate is going to be our majority element for this given array. Now let's try to run this code. As you can see that we have both the test cases as accepted. Now let's try to submit this code, and we get an accepted solution. So I hope you understood how to solve the majority element problem. And in the next video, we are going to solve the 6th problem from this top interview 150 list from Leetcode.